Hello dear students, let us discuss about exponential functions. So this is the definition of exponential function, natural exponential function. The natural exponential function, it is denoted by exp. To denote exponential function, and it is the function satisfying two conditions. First one is ln of x expx, which is equal to x for all x belongs to minus infinity to infinity, and exponential function of that is exp of ln x equal to x for all x belongs to 0 infinity. We will prove that this is exp of x is nothing but e raised to x. Let us see later. Okay, so equivalently, exponential of a function, that is exp of x equal to y if and only if ln y is equal to x. Now the domain of exponential function is a set of all full set of all real numbers, that is minus infinity to infinity. The interval range is 0 to infinity, that is expx is always positive. And here we know that this exponential function and ln logarithmic functions are inverse functions. Therefore ഇവിടെ ഡൊമൈൻ ഓഫ് ഇ എക്സ് പി മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി ആണ്. അതാണ് എല്ലിൻ്റെ റേഞ്ച് വരുന്നത്, മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി. സിമിലർലി റേഞ്ച് ഓഫ് exponential function is 0 to infinity, that is domain of ln is 0 to infinity. Okay, since they are inverse functions. Now this is the graph of exp of x, that is since it is the inverse function. If this red line is ln x, then exp of x, it can be obtained by reflecting the graph above the line y equal to x. നമ്മളിതിന് മുമ്പ് കണ്ടിട്ടുണ്ട്, ഇങ്ങനെ ഇൻവേഴ്സ് ഫംഗ്ഷൻ ആണെങ്കിൽ y ഈക്വൽ ടു എക്സ് എന്ന് പറയുന്നതിൻ്റെ രണ്ട് വശത്തിലും റിഫ്ലക്ഷൻ ആയിരിക്കും. അതായത് ഫംഗ്ഷൻ എന്താണോ വരയ്ക്കുന്നത് അതിൻ്റെ റിഫ്ലക്ഷൻ ആയിട്ടാണ് ഫംഗ്ഷൻ വരിക. ദാറ്റ് ഈസ് ഇവിടെ ln ഓഫ് എക്സിൻ്റെ റിഫ്ലക്ഷൻ ആണ് എക്സ്പോണൻഷ്യൽ ഓഫ് എക്സ്. ഓക്കെ, സോ നെക്സ്റ്റ് വൺ നമ്പർ ln is equal to integral 1 to e 1 by t dt is equal to 1. Since by definition we know that ln of x is equal to integral 1 to x 1 by t dt. Okay, ln of e means integral 1 to e 1 by t dt, that is ln t 1 to e ln of upper limit minus lower limit. Upper limit is e, lower limit is 1, that is ln of e minus ln of 1. ln of, we already proved that ln of 1 is equal to 0, and ln of e raised to x, ln of exponential of x is equal to x, that is ln of e raised to 1 is equal to 1. Therefore ln of e is equal to 1. And here e is an irrational number and it is approximately equal to the value 2.718281828, and we can be plot integral 1 to e 1 by t dt as the area between the curve y equal to 1 by t and x-axis integrating from 1 to e as shown in this figure. Okay, now this is again natural exponential function. We already proved that it is exp of x satisfying certain conditions, and exp of x is nothing but e raised to x, that is e raised to x equal to y if and only if ln y is equal to x. Okay, this is the definition of natural exponential function. And ln of e raised to x equal to x, also e raised to ln x equal to x. ln and exponential functions are inverse operations. ln of e raised to x is x. Similarly, e raised to ln x is also equal to x. Now let us solve some problem. First problem is we have to solve e raised to 2 minus 3x equal to 6. By using the fact ln of e raised to x equal to x, we can solve this problem. So first we are taking logarithm on both sides. That is ln of e raised to 2 minus 3x equal to ln of 6. Ln of 2 minus 3x means it is of the form ln of e raised to x, that is x. Therefore 2 minus 3x equal to ln of x. From that we will get 3x equal to 2 minus ln x, and x is equal to 1 by 3 into 2 minus ln x. By using calculator and by finding the value of ln x, we can find the value of x approximately equal to 0.0694. Okay, so this is our next problem. Solve ln of 2x plus 5 is equal to 4. So we are given that. So we can solve this problem using the fact e raised to ln x, that is exponential of ln x is equal to x. So we are exponentiating on both sides. We will get e raised to ln of 2x plus 5 equal to e raised to 4. That is, again we are using the fact that e raised to ln x equal to x, that is e raised to ln of 2x plus 5 is nothing but 2x plus 5. The right side is e raised to 4, and by simplifying we will get x is equal to e raised to 4 minus 5 by 2. And by finding the value of e raised to 4 by using calculator, we will get x as the approximate value of as 24.80. Okay, so next problem, find limit t tends to infinity e raised to 2t plus 1 by e raised to 2t minus 1. We know that limit x tends to infinity, e raised to x is infinity. Now this is infinity by infinity form. Okay, but we also know that limit x tends to minus infinity e raised to x equal to 0. So ഈ ഒരു ടേമിലേക്ക് ചേഞ്ച് ചെയ്യാൻ വേണ്ടിയിട്ട് both numerator and denominator we are dividing with e raised to 2t. Okay. So numerator എന്താ വരിക e raised to 2t plus 1 by e raised to 2t. Denominator is e raised to 2t minus 1 by e raised to 2t. Okay. So right side numerator become this is 1 by e raised to, that is e raised to 2t by e raised to 2t plus 1 divided by e raised to 2t. This is our numerator. That is e raised to 2t by e raised to 2t is 1. 1 by e raised to 2t is e raised to minus 2t. Similarly, denominator will become 1 minus e raised to 2t. Now we are applying the limit t tends to infinity. We know that limit t tends to infinity, e raised to t equal to infinity. That is, limit t tends to infinity e raised to minus t equal to limit t tends to infinity 1 by e raised to t equal to 1 by e raised to t. Limit t tends to infinity e raised to t ഇൻഫിനിറ്റിയിലേക്കാണ് കൺവേർജ് ചെയ്യുന്നത്. സോ ഇത് 1 by ഇൻഫിനിറ്റിയിലേക്ക് കൺവേർജ് ചെയ്യും. ദാറ്റ് ഈസ് വാല്യൂ 0. Therefore the value is 1. So these are the properties of natural exponential functions. Domain is minus infinity to infinity. Range is 0 to infinity, only positive values, and it never becomes 0. Note that a raised to x is never 0. It is 0 only when this exponent means x e raised to x converges to 0, only when this x converges to minus infinity. Okay, the function f of x is continuous. This is an exponential function. This is continuous and is increasing. Increasing means f dash of x is again e raised to x. E raised to x is always positive, which means f dash of x is greater than 0 means it is increasing. And f double dash of x, f dash of x is e raised to x. F double dash of x is again e raised to x, again which is positive, which means it is concave upward. Okay, so it is concave upward and it is increasing like this. And limit x tends to minus infinity e raised to x is 0, and limit x tends to infinity e raised to x equal to infinity.